All right, chemical bonding. Atoms bond because they want to be more stable. And atoms are stable when they have full outer electron shells. So we talked earlier about the fact that the electrons are found outside the nucleus in these energy levels, these shells. Okay. So when we have an atom and we have a nucleus in here, and let's just say we have, let's do helium. Helium, this is the nucleus, has the abbreviation capital H, lowercase e. Helium has 2 protons and 2 neutrons in its nucleus. And then in the first electron shell, there's going to be 2 electrons. So I'm making the electrons lowercase e with a negative. So this is what helium looks like. If we had something, so the first electron shell can hold a maximum of 2 electrons. The second shell would hold a maximum of 8, and then the third shell can hold a maximum of 8. And this is a pretty simplistic view of this because if you know chemistry, you know that there's a difference between shells and energy levels, or shells and orbits. So we should just say this is very basic, and this is really as far as we need to go. Okay, so this is a great representation, just showing what these look like. For example, here's the lithium. You can see lithium has an atomic number of 3 because it has 3 protons and it has 3 electrons. The number of electrons in an atom is equal to the number of protons if the atom is electrically neutral. Okay, so there's always the same number of electrons in an atom that doesn't have a charge. Okay, so there's helium. Let's just do carbon here because carbon's a common one. So carbon is number 6, so it's going to have 6 protons and 6 neutrons. Okay, and that's the nucleus right there. And then in the next shell, the first shell, remember, can hold a maximum of 2 electrons. Okay. And then the second electron shell can hold a maximum of 8. Okay. So, but there's only 6 electrons in there. So we already used 2 in the first one, so this one's only going to have 4. Okay. Here's sodium. Sodium has an atomic number of 11, so it has 11 protons. So it's going to have 2 in the first, and then 8 in the second. So that gives us 10 electrons accounted for. And it has to be 11 because it's neutral. So it has 1 in the third. Okay. So you should be able to use your periodic table in your book, and hopefully you can do something like chlorine. Try doing chlorine. Okay, see what you get. Okay, when atoms bond, let's talk about ions first. An ion is an atom that's electrically charged. So it either lost an electron, become positive, or it gained an electron, become negative. Cations are positively charged, and these formed when you lose electrons. Anions are negatively charged. So in this example, sodium will give up its electron to chlorine so it can have a full outer shell. So now its second shell is its outermost shell and it's full. And chlorine, which had 7 in its outer shell, will pick up that electron. But now sodium still has its 11 positives, but it only has 10 negatives. So that's going to make sodium with a +1 charge. And that's why sodium is sometimes written like this. Chlorine, on the other hand, still has its 17 positives, but it gained an extra electron, so it has 18 negatives, and that's why chlorine is usually written like this, Cl-. All right, ionic bonds happen exactly how we just started to describe them. They happen when electrons are transferred from one atom to another. And an atom transfers an electron when it wants to have a full outer shell. So what happens is when sodium, and we just described how this works, sodium here transferred its electron, it got a +1 charge. Chlorine picked up the extra electron and got a -1 charge. And those two are going to be magnetically attracted to each other because a positive is attracted to a negative. So that's how we get sodium chloride, because of an ionic bond. A lot of salts are made this way. And it's a really strong bond because it's a magnetic attraction, because the positive is attracted to the negative. Covalent bonding happens when electrons want to share, or when atoms share electrons. And this happens because it's one atom would not want to give up its electron to the other one, or it's an equal sharing. So here are these two hydrogens. Now, each of these hydrogens needs an electron to have a full outer shell. So the little blue balls here are the electrons. And this first shell, it needs 1 electron, and this hydrogen needs 1 electron to be full. So they will share their electrons here to both have a full outer shell. And since they have to share them, they have to be really close. So that's how the bonding happens, because the electrons are sharing the electron, they have to stay really close. So covalent bonds happen because atoms share electrons. All right, and then here's some more covalent bonds. You can see water. Water is a special kind of covalent bond, which we'll talk about next, I think, or soon. Structural formulas show how many electrons are shared. So, for example, with hydrogen, hydrogen is sharing 1 electron, so there's only 1 bond showed. Oxygen shares 2 electrons, so they are has a double bond, a double line. And you see carbon dioxide over here, same thing. Okay, so these are just the structural formulas. Here's water. The oxygen only has to share 1 electron with the hydrogen, and hydrogen shares its 1 electron with oxygen. Okay, here we are, polar molecules. Polar molecules happen because one of the atoms is more electrically negative, or has a greater pull for the electrons. For example, right here, this is an oxygen, and the oxygen is going to have 8 protons in there, and each hydrogen is only going to have 1 proton. So that means that the oxygen has a greater pull for the electrons because it's 8 positives. So the oxygen will keep the electrons more than the hydrogens will. And this is unequal sharing of electrons. But what this creates is oxygen with 8 positive charges, but usually 10 negative charges. So here's oxygen is going to be slightly negative because it has more electrons than it does protons. And the hydrogens are going to be a little bit positive because they're going to have one proton all the time, and sometimes they don't have any electrons. And when we have that unequal sharing, well, actually, probably a different slide. So that creates these hydrogen bonds. And hydrogen bonds happen because one oxygen is a little bit negative of one water molecule. So here's this one water molecule, and this is a little bit negative. But this hydrogen's a little bit positive because of those polar covalent bonds. So this one hydrogen is attracted to that one oxygen. And these are different water molecules. This bond, hydrogen bonds, are more like Velcro because they're easily broken, but then they reattach easily also. And then you've got this hydrogen of this water molecule is a little bit positive to be attracted here. And this is how water forms its liquid state. Okay, chemical reactions occur because molecules can combine and atoms can combine to form something new, or they can be broken down to form something new. So the reactants are the starting parts of the chemical reactions. So these are the reactants. This is the starting part. This is what you start with. And then the products are what you end up with. The arrow indicates that a chemical reaction is going to occur. Okay, so for this one, you have sodium chloride. It's going to be broken down into sodium and chlorine. All right, sodium and chloride. So that you have this positive and this negative. Types of reactions, synthesis reactions occur when you make something. So these are just random, these are just placeholders. So A plus B in a synthesis reaction forms AB, something that's new. These two are going to get together to form something new. Decomposition reactions is when you break things down. So AB, after the reaction, becomes A and B. Exchange reactions are when you take two molecules, two compounds, and A and B separate, and then A combines with D, so you go from AB plus CD to AD and CB. You have two different things. Reversible reactions are denoted by these double arrows because it can go in either direction. Okay, so the products can become the reactants, and the reactants can go back and become